Good morning, or afternoon, evening. Algebra 2 with Mrs. Krantz, Honors Algebra 2. Glad you could join us. Today, I think I'm going to post this on Monday, May 4th. May the 4th be with you. Honors Algebra 2 with Mrs. Krantz. Brand new chapter. Perhaps the last chapter we're going to cover for the year. Sequences and series. Chapter 9, we're going to start at the beginning, 9:1, and go through 9:5. This is a pretty short chapter on sequences and series. This is Mrs. Krantz, Monday, May the 4th, 2020, or whenever you're watching this. All right, what is a sequence? I think I may have put a general definition in front of you a second ago and got rid of it. But think about it, and I always ask and get a lot of good answers from you guys. But a sequence is simply a pattern or an ordered list of something. Okay, there has to be a pattern or an order to it. Okay, and it's a list of items, and ours are typically going to be numbers, but you could have some variables in there. There could be symbols, whatever it is. All right, it's a list of things in a particular order or pattern. Okay, and the things are called items or terms. Okay, so mostly we'll call them terms. The first term we call a sub 1. The second term, I think you can figure out a sub 2. Third term, a sub 3, dot, dot, dot. And what we're going to a lot of times be looking for is that elusive a sub nth term, the nth term, like the 100th term or the 20th term or something like that. All right, so this is going to be like a key term. All right. And then a lot of times we'll be looking behind that term to the one previous to it. And the previous term, all right, is just called a sub n minus 1. And the previous term before that would be a sub n minus 2. All right. Then what about the subsequent term, the term after the nth term? Well, that would be the n plus first term. All right, so if you kept going, you'd have a sub n plus 1. Then if you kept going after that, you'd have a sub n plus 2. Dot, dot, dot. Okay, so we're talking about a list of items, which are terms, okay, and they have a particular pattern or order or sequence to them. All right, now there are going to be two main types of sequences. All right, first is called a recursive sequence. Recursive, all right? It's a formula that defines terms by the previous term, okay? And we just learned that the previous term is called a sub n minus 1, okay? So now we're going to be working on some problems, okay? The problems in this chapter typically are not super long. Okay, they don't have a bunch of steps, but you're figuring out patterns or sequences, formulas, a way to describe what's going on, okay, in a sequence. All right. So the first type of formula, which is the less useful formula, all right, is one that defines the terms by the previous term. Okay. So write a recursive formula. Find the next term. Okay. Here the first term, a sub 1 is a half. Then the next term, a sub 2, is a fourth. Then the third term is 1/8. Then 1/6, then 1/32. Dot, dot, dot. First you figure out what's the pattern, what's happening. Okay? Then we're going to write the formula, a recursive formula. All right. So for a recursive formula, first you just list what the first term is. A sub 1 is a half. Okay. Now, what's the formula? How do I get a sub n? Okay. How do I get any particular term? Well, I take the previous term, and what's happening? All right, what's happening to these terms? Are the terms going up or down? Well, they're going down, right, in value, right? So if they're going down in value, maybe you're subtracting, maybe you're dividing, right? Or division is the same as multiplying by something, a reciprocal, right? So what's happening here? You are multiplying by a half each time, right? So the formula is a sub n equals 1/2 of the previous term. And that's it, all right? Now, you could write this as a division. You could say the previous term, a sub n sub 1, a sub n minus 1 divided by 2. All right, this is probably the better way to write it. This way is okay, all right? But you always also want to write the first term for recursive, okay? So either one would work. How about the next one? All right, and you guys in my honors class, you're always really pretty good at figuring these out, right? Because that's why you're in the honors class, because you understand and you see patterns and an order to a lot of things in the world, all right? So let's take a look. What's happening here? We have 6, then 1, then -4, then -5. All right, ooh, what's the next term? Actually, we didn't do that on number 1. What's the 1, 2, 3, 4, 5? What's a sub 6? Well, it's 1/32 times a half, right? 1/64. Okay. What's the next term here? Why don't we do that first? 1, 2, 3, 4. What's the 5th term? Well, what's the pattern? What's the sequence? It's going down this time again, and by the same amount every time, by 5, right? So our next term would be -9 minus 5, which is -14. That's the 5th term. Okay. Now, let's write the recursive formula, right? What's our recursive formula? All right, a sub 1 equals 6. Always start out with the first term. Then how do you get the next term? Well, you take the previous term and simply -5. Done. Okay. I'm going to write R for recursive, right? Because we're also going to be looking at the other type of formula, okay? All right. Next, what's happening here? This could be a little more tricky because it's going down, then up, then down, then up. So then you can't just be subtracting a number or adding a number every time. What's happening? How would I get the 1, 2, 3, 4, 5, 6th term on this one? What's the next term? You are taking the previous term and multiplying by -2. Yeah. So the next term would be -32. Okay. So to write the recursive formula, I write the first term. All right. Then a sub n equals -2 times the previous term. There we go. Recursive formula. All right, take the previous term times by -2. Then -2 times -2 is 4. And 4 times -2 is -8. And -8 times -2 is positive 16. All right. Okay, so these are recursive formulas. You need the previous term, all right, to get the next term. Now, what if you wanted to find, using these recursive formulas, like the 50th term or the 100th term, okay? These recursive formulas are not going to help that much because you need to know the 49th term or the 99th term, and you probably are not going to know that, okay? So there's another type of formula that's actually much more useful, and it is called the explicit formula. All right, I got it starred because it's a much more useful formula. Explicit means it explicitly is going to tell you, explicit, like in your face, explicit. This is what is going to allow you to get any term in the sequence, okay? It's a formula to obtain a specific term, any term, a sub n, like a sub 100, or a sub 50, or a sub 200, all right? In a sequence, and all you need to know is n, all right, using n. the term number, okay? N is the term number, all right? So we're going to do a couple of things here, right? We're going to write an explicit formula for these sequences, all right? Then we're going to find the 50th term, all right? A sub n means what's the 50th term, okay? Right. But on the first one, I'm going to actually have you write the recursive formula first, okay? All right. So before you write any formula, you have to figure out what is the pattern, what's going on. So first, you always have to figure out what's the pattern, okay? All right. And when you're given a sequence, there's always going to be a pattern. So, you know, we're not going to default say there's no pattern, okay? So what is the pattern? Hmm? I think you can look pretty quickly and figure out each time what's happening. It's going up by how much? 7, right? Okay. So recursive formula, first you write the first term. A sub 1 is 7, and then a sub n equals the previous term, a sub n minus 1 plus 7. Okay, done. All right. Now, this is what they really want to know. What's the explicit formula, okay? The explicit formula, okay? You don't have to write the first term, okay? We're just going to write what a sub n equals, okay? And all we're going to use is n and some other numbers, okay? Typically we have other numbers. Sometimes it's just equal to n, all right? But it could be something times n, something n minus something, n plus something, or like 8n minus 5, or n to a power, or whatever it is, okay? So now look at this. Each time it's going up by 7, okay? And for me, it's all about really looking at this first term, okay? So if I have this first term, and then I've got the second term, 14, the third term, all right, 21. Okay, because n's important, all right? How can I figure this out? Every time you're adding 7, so I'm going to start with 7 actually times n, all right? And see, does that work? Is that the formula? 7 times 1, 7. What's 7 times 2? 14. 7 times 3, 21. 7 times 4 for the fourth term, 28. That's it. That's the whole formula. All right? Take 7 times the term number. Done. All right. Now we can find the 50th term. All I do is take 7, use the formula, times n, which is 50, 350. Finished. Okay, sorry. All right. Next one. I won't write the recursive formula on this. We're just going to do the explicit. All right. What's the explicit formula? A sub n equals what? Well, what's happening? First, I have to figure out what's the pattern. Well, I think it's pretty easy to see. This is just going up by 1, by 1, by 1, right? Okay. So that would be 1 times n. All right, but now how do I get up to this first term? When n is 1, I need to get 5 for my first term. So I would have to add 1 plus 4. Okay, now does that work for the second term? Sure. 2 plus 4, 6. How about the third term? 3 plus 4, 7. Check. All right. So what would the 50th term be? 50 plus 4, 54. Okay. Let's try the next one. Look at 2, 8, 14, 20, 26. What's happening here? Well, going up again. All right, so a lot of these are going up. That's fine. All right. Is it going up by the same amount again? Looks like yes. Each time it's going up by 6. All right. So to start out with this explicit formula, all right, take that 6 and we're going to multiply it by the term number. Okay, 1. all right? But then it's about this first term. How do I get to 2? I know the first term is 2. So 6 times 1 gets me to 6, but then I have to go and subtract 4 to get me down to 2. Okay, for my first term. How about this? Does it work for the second term? 6 times 2, 12 minus 4, 8. Check. What about the third term? 6 times 3, 18 minus 4, 14. Check. All right. So how about the 50th term? That'd be 6 times 50, 300 minus 4, 296. All right. So once you find this explicit formula, it's really fast to get any term number you want. Right? We can get the 100th term, right? If I want to find the 100th term, all I do is 6 times 100, 600 minus 4, that'd be 596. All right? And these are typical problems you might see on an ACT or an SAT. They'll ask you to find like the 50th term or the 100th term, and they don't want you to get the first 49 terms or the first 99. It takes too long. You figure out the formula and you go. Okay? ACT, SAT problem. All right. How about next one? What's our explicit formula? Looks again like numbers are going up, and each time only by 1. All right, so when numbers are going up by 1, I just need a 1n or n. But now my first term is -1, so I'd have to take 1 and subtract 2 to get -1. What about second term? 2 minus 2, 0. Check. Third term, 3 minus 2, 1. Check. Works out. All right, so that's a pretty easy formula. Now, I haven't been writing a sub n equals. I probably should. All right. All right. Now, what about the 50th term? A sub n, 50 minus 2, 48. Okay. Next one. What's happening here? Going up again. All right. By the same amount, up by, looks like 2, yep. Going up by 2. So how about this explicit formula? All right. Up by 2 each time means I'm going to multiply by 2. Then how do I get to this first term? 2 times 1 is 2. I need to add 1 to get up to 3. All right. Does it work for the second term? 2 times 2 plus 1, 5. How about the third term? 6 plus 1, 7. Check. All right. How about 50th term? 2 times 50 plus 1, 101. All right. 6. We're going to do a bunch. What's happening here? Ooh, this time going down. Right? What's the explicit formula? I'm going to write a sub n equals. I should be doing that on these. All right. Now, looks like the numerator is always 1. How about the denominator? Well, the denominators each time are going up by 2. So that would be 2n. Now, do I need to add or subtract anything off of that? Well, if n is 1, 2 times 1 is 2. N is 2, 2 times 2, 4. 3, 2 times 3, 6. Check. There we go. All right. How about the 50th? 1 over 2 times 50. That gives me 1/100. Okay. All right. All right, we'll do a few more. 7, 8, 9. And we have a couple challenge ones. Okay. 7. Let's take a look at this. I'm starting out with 2. And then I'm going down to 2/3, down to 2/9, down to 2/17, down to 2/81. All right. What's the explicit formula for this? What is a sub n equal? Well, these are all fractions, are they not? Right. Except for the first one, but really you could make it over 1, right? Okay. So first thing I'm going to note in this pattern, I think I see 2 always on the top. Okay. So then let's see what's going on in the denominators. Okay. First term, second term, third term, fourth term, fifth term. Now, I've got 1, then 3, 9, 27, 81. Now we need to kind of look and see, these are special numbers. 3, 9, 27, 81. 1 doesn't quite fit that pattern, but could we get it to be in that pattern? Think about this for a second. What could I put down here? I need to have my n down there. And notice, this is 3. 9 is 3 squared. These are special numbers. 27 is 3 to the 3rd. 81 is 3 to the 4th. Looks like I'm going to have 3 as my base. What about my exponent? It's 4 when n is 5. Here the exponent on the 3 is 3 when n is 4. So what would that be to the n1? What do I do? N minus 1 power? 4 minus 1 is 3. Right? Does that work? Like, say, the third term, a sub 3, we're going to check this, right? It's 2 over 3 to the 3 minus 1 second power. Check. How about the first term? 2 over 3 to the, what's 1 minus 1? 0. Oh yeah, that works too. Okay. Nice. There's our explicit formula. All right. N could be as an exponent. All right. You could add or subtract n. You could divide by n. All right. N could even be the base. All right. Sometimes these can get a little bit tricky. All right. How about the 50th term? That'd be 2 over 3 to the 49th power, and we'll leave it at that. Okay. 3 to the 49th is really kind of a big number. All right, number 8. What do we got here? 9, 16, 25, 36, 49. What's a sub n equal? Look at these numbers. Are these special numbers? Right? What's 9? 9, 3 squared. Ooh, what's 16? 4 squared. Yeah, these are our perfect square numbers, right? So how am I going to write that as an explicit formula? What's a sub n equal? Well, I need my n. Let's see. And here n is 1, n is 2. All right, how am I going to get that? All right, I'm going to have to take n, my term number. How do I get up to 3? From 1, I'm going to add 2 and square. All right. And let's just check that. Does that work like for the 4th term? A sub 4. That's 4 plus 2, 6 squared. Oh, check. All right. So what would the 50th term be? Well, that'd be 50 plus 2, 52 squared. That's not too big. We can do that. All right. 2,704. Okay. All right. How about 9? Take a look at 9. That one down, this one up. These are back to going up. Okay. 28, 65, 126, 217. Now here I had special numbers. Are these special numbers? Look at that. Are those special? I don't know. Maybe. Are they going up by the same amount every time? Or is there a pattern to the amount that they're going up by? This one's by 37. next one's going up by 61. All right, I'm trying to figure out the pattern. Then going up by 91. I don't know if I see a pattern on that. Okay. Do you see something? All right, what's the pattern? Let's try to write this out. Well, I notice these are not special numbers, but they seem to be close. All right. 28 is really close to 27. 65 is close to 64. 126 is close to 125. 217, oh, 216. Those are special numbers. What are these? These are perfect cube numbers. So now I'm gonna have something cubed. What am I gonna have cubed? Well, this is my first term. I'm gonna have something cubed. This is 3 cubed, 4 cubed, 5 cubed. All right, 3 cubed. So I have my 1. I'm gonna have to add, looks like 2 again. 1 plus 2 cubed. All right. Does that work for 2, 3, the 4th term? 4 with 6 cubed, yes. All right, so what would the 50th term be? Well, this one's 52 cubed, which that's not too big. It's sort of big. 140,608. All right. Now, last one I'm going to do with you, and then 11 I'm going to leave for you to figure out. Okay? And these two we're going to write with what I call a hybrid formula. Okay? So not only are we going to use n, the term number, we're also going to use the previous term. Okay? All right. So first we have to look at it and always figure out what's the pattern. Okay? And then how can we write the pattern as a formula? Okay? So it's this thing. Figure out the pattern first, then the formula. All right. Okay, what does this equal? Let's see. 3, 5, 9, 15, 23. Are they special numbers? You know, are we adding something? Are you subtracting something? Are you multiplying, which is really dividing? Right? Are you squaring the number? Are you cubing it? That kind of thing. Are you square rooting it? You know, these are kind of our options here. Okay. Well, I look at this. I personally see this goes up by 2. Then I see it goes up by 4. Then I see it goes up by 6. Then I see it goes up by 8. 1, 2, 3, 4, 5. So what would a sub 6 be, the 6th term? Well, 2, 4, 6, 8. I think it's going up then by 10. So that'd be 33. Okay. I think we discovered the pattern. Up by 2, then by 4, then by 6, then by 8, then by 10, then by 12. So it's up by 2 more each time. Right. So what that can typically mean is we're going to go 2 times n. Okay, but that's just the beginning. All right, so let's try that. 2 times n, 2 times n, 2 times 1. That gets me at 2. Let's look at the second, third term. Let's look at the second term. All right. So that'd be 2 times 2. That would, if I'm looking at the second term, 2 times 2 would get me up to 4. Okay. All right. Now I'm going to look at the previous term. Let's say we add the previous term. That's 3. Okay. But what do I need to be at? I need to be at 5. So I'm going to go 7 minus 2. That gives me 5. Well, it works for the second term. Okay. Now you got to figure out, does it work universally? Does it work for the third term, fourth term, fifth term? All right, well, let's try the fourth term. All right. Okay. So 2 times 4, that'd be 8. All right. Then we're going to add the previous term, 9, subtract 2, so 15. Ah, it works. And if we check them, it'll work for the 6th term, the 7th term, the 8th term. Okay. Now, so this last one is your first homework problem. All right. Figure out the pattern on this using n and a sub n minus 1. All right, starting out with -2, 1, 8, 19, 34, 53, etc. All right, figure out the explicit formula. And I want you to find a sub 10, 10th term. Okay, I'll put this on Google Classroom too. All right, so this is an introduction to sequences with Mrs. Krantz, Honors Algebra 2, and I will post an assignment in the book. Have a good day, guys.